Hi, everyone. Here's a quote from Paul Dorman on sciencing.com. He says, being able to find the roots of second-order polynomials comes up regularly in projectile problems and acid-base equilibrium calculations. Chemistry, physics, finance, numerical analysis, matrix factorization are some of the many uses of factoring polynomials in the real world. 6.6, we're going to be solving quadratic equations by the factoring method. So by the end of this section, you should be able to solve quadratic equations by factoring, solve higher degree equations by factoring, and find x-intercepts of a quadratic equation in two variables. So a quadratic equation is one that can be written in this form: ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a can't be 0 because then this would just be a linear equation, not quadratic. So the form of this equation that I gave you is referred to as the standard form. Suppose that you were told two factors multiply to 12. Could you tell me with some certainty what those factors are, either one of them? There's a lot of possibilities, right? You could have 3 times 4, 6 times 2, 12 times 1. You could have both positive, both negative. So you can't really tell me with some certainty which either of those factors are. But suppose you were told that two factors multiply to 0. Could you tell me with certainty what those factors could be? Remember, the only way to get 0 as a product is if one or of your factors is 0. So there's something that we have called the zero product property, which says if a and b are real numbers, and if a times b equals 0, then either a is 0 or b is 0. So those would tell us that we know one of those factors has to be 0, and that will give us a solution to that equation. So in the next videos, we'll learn about solving quadratic and higher degree equations using that zero product property and how to apply this concept to finding x-intercepts.